Okay, so hopefully you've already read about conditional probability in the text. We're going to look at 3 examples that are distinctly different from one another. So let us begin with this one. What is the probability of drawing a queen given that it is a face card? All right, we're assuming we're drawing from a standard deck of 52 cards. So remember, your face cards could be jacks, queens, or kings. So there are 3 options. And we want to know what the probability is that it would be a queen given that we know it is a face card. Right? So it's as if your friend drew a card from the deck and he looks at it and says, ah, it's a face card. What are the odds that it is a queen? Right? I think you already know the answer, but let's figure out how this works using sets. All right, so if we were to draw this out, we have the set of face cards. All right, so let's do that set first, okay? The set of face cards would have the Jack of Hearts, the Queen of Hearts, and the King of Hearts, the Jack of Diamonds, the Queen of Diamonds, and the King of Diamonds. Whoops, I may not have made this. Jack of Clubs, Queen of Clubs, King of Clubs, and I'll have to get real small here, Queen of Spades, and the Queen or King of Spades. Should have made that a little bit bigger, okay? And out here are the rest of the cards. Not going to write them all down because there are a lot of them. Okay, so looks like we have 12 cards in this set. Now, if we want to look at the set of queens, it is this large. Now, you can see that the set of queens is completely a subset. It's inside of the set of face cards, right? So to figure out this probability, we would just have to know how many queens there are out of how many face cards there are. So the probability is 4 out of 12, or 1 in 3. Okay. Now the book had a formula for this. It said, if you want to find the probability of E given F, right? So this line right here, when we're talking about probability, is used is for the word given. So that means we know that F must be true. Sometimes in math, that line might be read as a with. Okay, but for now it's a given. So we know that F must be true. Therefore, we've eliminated, so out of the other cards, it looks like there would be 36 other cards out here. It can't be one of those, all right? So the denominator of our probability can only be the 12. That would be for the face cards. And 4 of those would be queens, so we have a 4 out of 12 chance. Right? Now the formula said we should look at the probability of being in E intersect F divided by the number of things in F. Well, that's exactly what we did, okay? The intersection of, I'm sorry, it's not a P here, it's the number of elements or objects in E intersect F over the number of objects or elements in F. So there were 4 queens that were also face cards. So this was the 4 queens over the 12 things left in F. So we don't have to worry about the other 36 cards that are not inside of F. Okay, so that's one example where the first being a queen is a subset of being a face card. Okay, so now we've just reversed the question. What is the probability of drawing a face card given that it is a queen? All right. So there are 2 ways you could think about this. This is as if your friend drew a card out of the deck and says, ah, I have a queen. What are the chances that it's a face card? I think you know the answer. It has to be a face card. The other option is we get the set of queens out of the deck and shuffle those, and then you're about to draw a card. Well, you can be 100% confident that you are going to get a face card, all right? So let's look at that in terms of a diagram. Okay, so the set E is the set of all face cards, right? Set F is the set of all queens. Well, as we saw, the set of all queens is inside. It's actually the picture above. I won't bother redrawing it, Okay, so we have the set of queens inside of that. Okay, now this time E is the set of face cards. So it's the bigger of the two. F is the set of queens. But we already know that what we have is inside of the set of queens. So what is the probability of E given F? Well, we know it has to be 100%. So it's the number of objects in the intersection of E and F over the number of objects in F. Well, now F is the set of queens. The intersection has 4 objects in it. There are 4 queens in this that are also face cards. And how many queens are there? There are 4 of them. So this ends up being 100%. Right? The last example was like 33. We would usually call that 33.3%. It's 33.3 repeating, but we usually would just call that 33% or 33.3%, or just 1 in 3 as the probability. So this is a case where it's a 100% probability. If you know you have a queen, you know you have a face card. Let's look at one final example. Okay, so what is the probability of drawing a face card given that it is a spade? Okay, so remember our analogy. This is as if your friend drew a card from the deck and says, I have a spade. What are the chances that it's a face card? And you would be answering that question. Or conversely, you took everything, you only took the spades out of the deck, shuffled those up, and you were going to draw a card. Okay, so that's what is going on here. So you know that it is a spade. So that is given. So something happened that required this, I'm sorry, I've got a little glitch here, is requiring that this thing is a spade. So let's draw it out. So now we have event E is going to be, what is the probability of it? That would be the face cards. Okay, F is a spade. We know that some face cards are spades, but not all face cards. So we can draw a diagram that looks more like the typical Venn diagram with some overlapping regions. All right, let's first figure out what is in both. Okay, so who is in both? The face cards that are spades, that would be the Jack of Spades, Queen of Spades, and King of Spades. Those are all S's, right? Now, there are face cards that aren't spades, okay? So those would be the Jack of Diamonds, Queen of Diamonds, King of Diamonds, Jack of Hearts, Queen of Hearts, King of Hearts, and then finally with a Jack of Clubs, Queen of Clubs, and the King of Clubs. So all of those are face cards that aren't in the intersection, right? And then we have plenty of spades that are also, that aren't the 3 that we already picked. We have the 2 of spades, the 3 of spades, the 4 of spades, the 5 of spades, 6 of spades, 7 of spades, 8 of spades, 9 of spades, and then we get to the Jack, King, Queen. Oh, and we also have an ace of spades. All right, so we have all of those options that are not, that are not face cards, right? And then we have the rest of the deck out here. So these are the non-face cards and non-spades. I'm not going to write out what all of those are, right? So this one is where the formula might be a little bit more useful. We need to find the probability of being a face card given that it is a spade. Okay, so we need to look at the number that are in the intersection of E and F over the number that are in F. Okay, now let me highlight what this is saying in green. I'm going to circle what is set F. Okay, so we're not worried about all of the stuff that was over there. Okay, because we've been told it can't be the Jack of Hearts because we know it's a spade. So all of those things that are over there or that are in the rest of the deck don't matter because we know that we're inside of the green circle. So knowing that we're in the green circle already, we know that there are 13 cards in the green circle, and 3 of the 13 will end up being ones that could be useful. Okay, so let me just double 9 and I'm sorry, not 13. That's 3 out of 52. Yes, it is 3 out of 13. Let me just make sure I have my numbers correct here. Yes, it is 3 out of 13. The reason I was confusing myself is I forgot that the standard deck of cards has a 10 in it, so there would have been a 10 of spades. I'm sorry about that. So the probability is 3 and 13. Since those are both prime numbers, they don't reduce. You could convert it into a decimal or a percentage, but your odds are 3 in 13 that you would have a face card given that you have only spades.